Today we are going to look at writing exponential functions from a word problem. So in each of these examples, you're given two situations. One of them will be linear and one of them will be exponential. So first you have to identify which function is exponential and then write that function. So if I'm looking at this first problem, situation 1, little Annie finds 20 ants outside and decides to keep them as pets. She feeds them once a week and counts how many ants she has. The population of her ant farm is as follows. She has 20 ants in the first week, 110 ants in the second week, 200 ants in the third week, and 290 ants by the fourth week. Situation B, Grandpa Joe collects books. The number of books he buys each month is as follows. 8 books on the first month, and since these numbers are written out in word form, it might help you if you write it out as a number. So 8 books in the first month, 64 books on the second month, 512 on the third month, and 4,096 books in the fourth month. Okay, so now looking at these two numeric sequences, 20, 110, 200, 290, and then 8, 64, 512, and 4,096, which one looks exponential? Meaning which one looks like it's increasing at a quick rate? That is one of the bigger indicators of it being an exponential function, if you're increasing or decreasing very quickly. So in this case, situation B looks like it's increasing quickly. So in this first one, just to make sure, I'm not multiplying anything to get to the next term, but I am adding 90 each time. So plus 90, plus 90, plus 90. So this one is clearly linear because we're adding 90. In this second one, let's figure out what we're multiplying to get to the next term. So we'll go 64 divided by 8, meaning that I am multiplying by 8 to get to the next term. Let's see if it works for 64. 64 times 8 is 512. Perfect. And if we multiplied by 8 again, we would get that 4,096. Okay, so situation B is our exponential. Now we want to write the function y equals a times b to the power x. A is our y-intercept, and b is our multiplier. So in this example, a little tricky because our y-intercept is 8 and our multiplier is also 8. So a little bit tricky there, but there is our function, y equals 8 times 8 to the power x. Let's get rid of Desmos, oops. And let's try this next one. So situation C, Patrick wants to buy some flowers for his friend, so he gets a new job as a butler. His paychecks are as follows: $1 on the first day, $2 on the second day, $4 on the third day, $8 on the fourth day. So not increasing very quickly. Situation D, Timothy decides he wants to improve his grades. He plans on studying each night. His studying pays off and his grade is as follows. He has a 1% on the first week, a 10% by the second week, 19% by the third week, and 28% by the fourth week. So those numbers look like they are increasing much quicker. So let's verify and see if our kind of predictions were correct. So for this first one, well, if I'm looking at addition, plus 1, but then for this next one, I'm adding 2, and then I'm adding 4. So that's not linear. Let's see if it's multiplication. 1 times what is 2? I can multiply by 2. Does that work for the next set? So 2 times 2 is 4, and 4 times 2 is 8. Oh, so this one seems to be exponential. Let's double check with that situation D just to make sure. So if situation C was exponential, that must mean that this one is linear. So let's verify that it is linear. So 1 plus what equals 9, or equals 10? I just gave you the answer. Adding 9, 10 plus 9 is 19, and 19 plus 9 is 28. So this one seems to be linear. So that means that situation C is our exponential. We'll write our function out. Y equals a times b to the power x. A is our y-intercept, so our first value, which is 1. And my multiplier, we multiplied by 2 each time, and then to the power x. Okay, so there are 4 more examples for you to work through on your own. Let me know if you have any questions.